once again in Poland. We are delighted that you are teaching our meeting again. I have a few questions for you.
Okay.
Lee, why EMC?
Why EMC? It's the career that saved my life from college. Electrical engineering was difficult for me, and I had a co-op job in EMC, and I found something to be interested in, and it's been a great career. And everything from the airplane that brought me here to the coffee maker that we were using at lunch break depends on EMC in some way or another. Most people walk around on the planet completely unaware of it. Those of us who are involved in EMC, we can't help but see it every step we take during the day. The microprocessors, electrical circuits that we depend on are everywhere, and we need them to work okay.
Exactly. And that's why it's so important, I guess.
Yeah, and now unfortunately with the world increasingly having military action, the lives of people depend on EMC. Warfighters, whether they're depending on breathing apparatus or their aircraft, or their lighting or their security, EMC is so important to keeping them alive as they risk their lives.
Okay. Where did it come from in your life?
So in my life, I had a co-op job when I was in undergraduate university. We were required to get 15 months of work experience before we would get our diploma. And one of my co-op jobs was in a very small EMC test group at a computer company in Rochester, New York. And up to that point, I was ready to leave electrical engineering. I didn't find anything interesting about it. In fact, I hated it. I wanted to be an interpreter for the deaf. And I came back to electrical engineering class, and it was just terrible. But then I had this co-op job in EMC at this computer company, and I found that I really liked it. I liked the idea of using radio receivers and antennas to measure noise. And I thought, well, if I can understand how to design electronics and fix electronics, this will be a pretty good skill. Not many people were interested in this. In the 1980s, everybody wanted to be a digital design engineer. Nobody wanted to be an analog design engineer, and nobody wanted to be an RF engineer. And nobody even knew what an EMC engineer was. So when I was interviewing for full-time jobs in the university, and I told the interviewer from the computer company that I wanted to be an EMC engineer, his eyes just got really big, and he jumped up out of the chair and started talking to me about their company and how they needed people to work on these new EMC problems. So it started off in college, and I got my first job in EMC, and then 5.5 years later, I started my own company in EMC, and it's been the way that I've made a living and put kids through school.
And now we are here.
And now I'm here coming back to Poland for, I don't know if this is maybe number 6 that I've been here. And I have grandparents that came from Poland. So I've moved to Europe, and coming to Poland is always really special because in some way I'm coming home, and not many people get that chance. And it's of course, it's not, the home is a confusing place when you live in the United States and move to Europe, but it's always great to come here.
And I guess it's not easy.
People say travel is difficult. You walk up some stairs into a metal tube, and you sit back, and then 6 hours later, you're in a completely different place with a completely different language, and all you did was sit there. So it's magic. The time shift is hard, but I think travel is magic if you're lucky enough to be able to do it.
I agree.
Yeah,
definitely. Why training? Why courses?
That's a good question. When I was back, I think even in high school, I was interested in tutoring and teaching for some reason. I think kids who think they're smart, they want to show all of their knowledge and they want to teach somehow. When I was an undergraduate student, I got involved with a tutoring group at the university for underprivileged, low-income city kids. And it reminded me of where I grew up. And so I helped out in the special tutoring group with kids from city neighborhoods in Rochester, New York. So I began tutoring even when I was in undergraduate school. And a college advisor told me that, one reason to stay with electrical engineering, to tough it out and finish my degree was even if I wasn't crazy about electrical engineering, if I could get this degree, I would be able to teach. And that really became my motivation to stay in school, was this opportunity that maybe sometime in the future I would teach. And not too many years later, I started teaching little bits of EMC courses at my company, at my full-time job, and then ended up starting to teach classes for my own company. So it went way back. And I think I've always admired most of the best teachers. They're among the people that I hold in highest regard, as the people who commit their lives to teaching.
Nice one.
Yeah.
Very impressive.
Thanks.
Please tell us about your first impression of the course and the participants. Yeah, I know it's the first day, but you can also tell us a little bit about it.
So every class is a different, unique combination of people who have never been together before. So it's it's impossible to predict what the course chemistry will like, what the atmosphere will be like. Usually, in some countries in Europe, people are compared to the United States, where we are a little bit crazy, people are a little bit more calm, a little bit more reserved. They don't speak up too much. They're very respectful and they listen. So what usually happens here in Poland is the class is very quiet for a while, and people are watching and they're thinking, and then they start to ask questions. People start to get in the idea of the rest of the group to ask more questions. But here I have to be very comfortable with quiet, with no feedback, because that means people are listening very carefully and they are enjoying it. That quiet indicates, yes, I like it, please give me more, keep going, I don't want to interrupt you. And in the beginning of teaching, sometimes that can be a little bit not upsetting, but it can be a little bit, it's a different reaction than what some Americans are used to. So I've been lucky enough, I've been teaching in different places outside of the US for a number of years, so I'm comfortable not expecting anything not to try to be louder or try to be funny, which is hard for an engineer anyway. Try not to make something happen that is not naturally happening. Just deliver the class, pay attention to every student, and then just be patient. Yeah.
Nice one. We know very well that the industry has changed, of course, for defense nowadays. Tell us how important the EMC is in the military sector.
So my business partner and I, out of all of our customers, we maybe do 5% of our work in the military sphere and military aerospace and defense equipment. So we don't have a steady diet, I would say, of military electronics, but we do work on some on a regular basis. And because we don't have high top secret clearances, we don't get exposed to a lot of the most important stuff that's happening, I'm sure, in the world. So I don't know what I don't know. EMC and military electronics is always so important because people's lives are at stake. The warfighters, safety and ability to survive and go home, to their family is the most important thing. So. Yeah, when I teach classes to people involved in defense electronics, I tell the stories of EMC disasters, of where people were lost their lives on ships, in helicopters, because of EMC design mistakes. And our customers, the people at those military electronics companies, they tell me, Lee, we want you to tell those stories. We want to make sure that people are aware of EMC and that it's very serious, because unfortunately the bad stories remind us of how important it is. When people lose their lives, we never want that to happen again. So I don't have a lot of experience in military electronics compared to other people who have security clearances, who work in the defense sector all the time. They know much better than I do. But in the end, we all know somebody who's been in military service. And of course, we want them to serve and we want them to come home.
Yes, it's very important what you said, yeah. In what direction will EMC develop? What determines this development?
It's a big question.
What do you think?
What direction is if the past is any prediction, people always say, what is it? The past is usually a bad prediction of the future, but electronics are everywhere. And everything is getting smaller. Lower power is good for EMC because our noise sources get weaker, but usually lower power means we have to be careful because our victim circuits now are operating at smaller voltages. They only need smaller signal voltages and smaller signal currents to produce a desired result. That usually means they're more sensitive, and they may be more sensitive to external noise events. The trend towards making everything digital is eliminating some noise problems. So digital sensors, where we used to have analog temperature, pressure, flow sensors, where now a lot of those things are digital microphones. We don't have analog microphones in digital electronics anymore. That makes immunity problems much easier to deal with. We don't have millivolt analog signals to worry about in audio paths anymore. So, as digital signaling takes over analog signaling, there's going to be some set of immunity problems that just go away, that we won't see anymore. In other areas, in power electronics, in power electronics, things are just getting faster and louder as far as noise sources. So people who are building high power energy conversion for electrification, photovoltaic, wind turbines, they are making big noise sources. They're making the biggest. So there's some paths in power electronics where the drive for efficiency often comes with increased noise, stronger noise sources. So there's some places where you can see a trend for a short amount of time, but beyond a few years, there aren't many people who have a good answer.
Thank you. Anyway, now few short questions. Short answers, if you like. Do you choose practice or theory?
Do I choose practice? When I'm teaching, it's theory always with an application of practice. When I'm troubleshooting a project, it's always practice first. If we're troubleshooting, we solve the problem, and then maybe we have a reasonable explanation. But sometimes we like to tell the customer, why is extra. We solve the problem. We have an exact understanding of why the problem happened. Well, that might be a 6-month or a 1-year research project at a university. Sometimes we can solve problems very quickly. Getting a root cause explanation can be a little bit harder. So troubleshooting is usually practice, and teaching a little bit of theory, and then the practical application.
And where do you feel stronger?
Where do I feel stronger? Well, when I'm teaching, I hope I'm equal.
Equal.
Yeah, I hope I'm equal strength, because I don't want to. I'm not comfortable teaching the theoretical without an application, because always my usual audience is people working in industry, and so they're not going to school for a degree. They're coming to a class to learn some practical applied skills. So a little bit of theory to make sure the practice makes sense.
Exactly. Thank you. Grounding or shielding? What do you recommend?
That sounds like an old beer commercial. Tastes great, less filling. You always have ground. So there are many products, commercial, consumer products, low-cost electronics, where there's no shielding. So in many cases, shielding is not an option at all, except in established interfaces, let's say USB, for example. And grounding, same thing. We could design many digital circuit boards. There is no ground. There's only signal return. There's no extra metal. So I would say in the lower cost digital electronics, there's probably no shielding or grounding at all, and we can still have good EMC. If we look at military electronics with very tough immunity and very tough emissions requirements, we probably have both, some parts of both.
Okay, thank you. Civilian industry or defense? Which has a future?
I hope both. I hope, well, actually, I hope defense electronics has a very limited future. I would love to think that we don't need defense electronics anymore, but that's never going to, practically with human beings, that's probably never going to happen. But I wish in some ways that we had very little need or much reduced need, but it's very clear we're going in the opposite direction because of world events. That's
Thank you very much.
Question.
Thank you very much.